In this problem, we need to solve the equation the natural log of 3x equals the natural log of x squared minus 40. What type of equation do we have? It's a logarithmic equation, and how many logarithmic terms are there? There's one on the left-hand side and one on the right-hand side. The majority of logarithmic equations that contain more than one logarithm fall into one of two types. The first type, every term is a logarithm. The second type, there's at least one term that is not a logarithm. Which case do I have here? I only have two terms, both of which are logarithms. So this is the type where every term is a logarithm, and we can solve those using the one-to-one property for logarithmic functions that states, if log to the base b of x equals log to the base b of y, then x has to equal y. It's important to note the base of the logs must be equal, and the coefficient of the logarithmic terms must be a 1. Do I have that in this case? Yes, the base of both of my logs is e, so it's the same, and the coefficient of each of my log terms is a 1. So since the natural log of 3x equals the natural log of x squared minus 40, using the one-to-one property of logarithms, I know that 3x equals x squared minus 40. And so I've gone from a logarithmic equation to a quadratic equation that is a lot easier to solve. So how do we solve quadratic equations? We want to get 0 on one side. So I'm going to subtract 3x from both sides. So I get 0 equals x squared minus 3x minus 40. Remember, write everything in descending order. And now, hopefully, it will factor. And it's one of the easier factoring problems since the coefficient of the x squared term is a 1. So I'm just going to have an x and an x. My two numbers multiply to a negative number. That means they have to have opposite signs in my parentheses. Multiply to negative 40 and add to negative 3. I think negative 8 and plus 5 will work. Two quantities multiplied together equaling 0 using the 0 factor property. We set each of them equal to 0. So x plus 5 equals 0 or x minus 8 equals 0. From the first one, subtract 5 from both sides, you get x equals negative 5. From the second one, add 8 to both sides, you get x equals positive 8. But remember, we're not done yet. We started off with logarithms in our original equations, so we must check for extraneous solutions. So let's check our first answer of x equals negative 5. And when we check logarithmic equations, all we need to do is make sure the arguments of each of the logs is a positive number. So checking x equals negative 5, we get the natural log of 3 times x, which is 3 times x is negative 5. Well, what's 3 times negative 5? Negative 15. We need the arguments of our logs to be positive. This is not a positive number. I don't need to check any other part of the equation. I now know x equals negative 5 is an extraneous solution. So now let's moving on to our next solution of x equals 8. Let's see if this one works. Plug it into the original equation. The natural log of 3 times x, so that's 3 times 8. 3 times 8 is 24. Is that positive? Good. Keep going. equals the natural log of x squared minus 40. X is 8, so it's 8 squared minus 40. 8 squared is 64. So I have 64 minus 40 is my argument, which is 24. Is that a positive number? Yes. So I have now proved that x equals 8 is not extraneous. But in this case, I've also shown that the natural log of 24 equals the natural log of 24. And as I have a true statement, I also know x equals 8 is a correct solution of this equation.